As you can see here, KOSMOS 2 is given an image of cows surrounded by vegetation. As specified by text prompt, the task here is for the model to identify the number of cows in the picture. Impressively, the model was able to detect that there are 2 cows in the image, capturing them with yellow bounding boxes. So, Microsoft just unveiled KOSMOS 2, a multimodal large language model that incorporates intuitive capabilities like zero-shot, grounding, and perceiving general modalities to process text and visual prompts. Essentially, KOSMOS 2 is a multimodal large language model that facilitates seamless interaction between humans and AI chatbots. This amazing large language tool takes multimodal AI technology to a whole different level. In case you're wondering, a multimodal large language model is a model that is trained to support multiple forms of input data such as text, audio, and video. Currently, the perfect example of a multimodal model that I can easily point to is GPT-4, because it supports both text and images as input. I know you're probably thinking, what about the GPT-3 and GPT-3.5 large language models? Well, these two are not regarded as multimodal language models because they only support one modality, which is text. So, in terms of modalities, KOSMOS 2 is similar to GPT-4, but critically, Microsoft has added quite a number of interesting features to KOSMOS 2, which makes it far more dynamic and precise than any other large language models in existence. We'll reveal these features in a bit, but first, let's have some background story to how KOSMOS 2 came about. Sometime last year, Microsoft introduced KOSMOS 1. Basically, KOSMOS 1 was a multimodal large language model trained on large-scale web data including texts, images, and their combinations. This smart tool was groundbreaking and achieved significant success in cognitive tasks. For example, it could write interesting stories from images, create image captions, and answer technical questions about any image it is presented with. However, it lacked the capacity to understand and connect visual information to make sensible illustrations. So, Microsoft went back to the drawing board, tweaked a few things, and came up with KOSMOS 2. In a recently released research paper, the Silicon Valley giant introduced KOSMOS 2 as a multimodal large language model, enabling new capabilities of perceiving object descriptions, example, bounding boxes, and grounding text to the visual world. When given an image as input, KOSMOS 2 imagines the picture as a chessboard. Essentially, the image is broken down into smaller units, where each unit is represented by a square box. Each square box is assigned a special tag that is subsequently added to the picture's description at the right spot. By doing this, the model is able to understand every single unit of the image and interpret it in words, facilitating better interaction between humans and AI-powered chatbots. In the research paper, Microsoft demonstrated the capability of KOSMOS 2 to take on several tasks such as multimodal grounding, multimodal referring, perception language, as well as language understanding and generation. In this example here, KOSMOS 2 is provided with a picture and a text prompt to which it is expected to respond. For the demonstration, KOSMOS 2 is provided with a picture of an emoji and a specific instruction to highlight the left eye. And as you can see in the completion section below, the model properly identifies the left eye of the emoji with a bounding box. In case you don't know, a bounding box is an imaginary rectangle or square that outlines the position and size of an object in a picture. Now let's move on to the next demonstration. As you can see here, KOSMOS 2 is given an image of cows surrounded by vegetation. As specified by text prompt, the task here is for the model to identify the number of cows in the picture. Impressively, the model was able to detect that there are 2 cows in the image, capturing them with yellow bounding boxes. In the third example, the model is given an image showing a sign. Underneath the image, you can see a prompt asking the model to reveal what the sign says. Compared to the other demonstrations, this example is a bit complicated because not only does the model have to identify the location and size of the object by drawing a bounding box around it, it must also identify and extract the words written on the sign. And as you can see in the completion section, KOSMOS 2 does very well with both tasks. These examples showcase the proficiency of KOSMOS 2 in identifying and calculating the number of objects within an image. But more importantly, it demonstrates its ability to read and extract the text embedded in an image. Before we explore a few live demos of this impressive tool, let's take a look at a few more demonstrations from the research paper. As you can see on the left side of the screen, we've got an image of a turtle and a rabbit. The turtle is highlighted with a blue bounding box, and there's a prompt here asking, why is this animal unusual? Looking at the image, my brain tells me that both animals are in a race. But let's see what KOSMOS 2 makes of it. Amazingly, the response in the completion section shows that KOSMOS 2 has a perfect understanding of everything that's going on in the image. Let's read out its response in full. The animal is unique because it is a turtle. Turtles are known for their slow and steady pace, whereas rabbits are known to be agile and quick. It is not common for a turtle to be faster than a rabbit, especially in terms of speed. In my opinion, this example is the best one we've seen yet because it demonstrates how KOSMOS 2 is able to understand the context and nuances of the image. In the next image, a small object is highlighted on the side of a boat with a prompt that reads, "What is it?" Observe that the word "it" is highlighted in red, which is the same color with which the object on the boat is selected. Looking at the object, it's hard to tell what, but as you can see from the completion section, KOSMOS 2 has no problem identifying it as a boy attached to the boat. The third example is even more complex because the input image shows two identical products, each highlighted with different colors of bounding boxes. Now, the prompt here is for KOSMOS 2 to identify the difference between bottle 1 and bottle 2. KOSMOS 2 was able to identify that the labels were different, and looking at it closely, we see that the fruit on the label of bottle 1 is lemon, while the fruit on the label on the second bottle is watermelon. The fact that KOSMOS 2 is able to recognize that a difference exists in the labels is quite good. I would have been really impressed if it would have given more details explaining what the exact difference is, but maybe the prompts need to be more specific to achieve that. After all, the question was what is the biggest difference, and it did answer it correctly. Now, aside from the examples in the research paper, there's a live demo version of KOSMOS 2 that anyone can play around with. Currently, the website is experiencing downtime for obvious reasons, but we put the link in the description so you can try it out yourself in case it becomes active later. Basically, with this live demo, users can insert any image and prompt of their choice. For instance, here, KOSMOS 2 is presented with a poor quality image of a plane wreck at the bottom of the ocean. If you look closely at the image, you'll see the ducted fans and wings of the airplane. And although not very visible, you'll notice that there are 3 divers in the picture. Right off the bat, the language model impressively identifies the plane wreck with what looks like a light ash bounding box. More impressively, KOSMOS 2 was able to identify the 3 divers without any. As you can see here, the diver on the right is highlighted with a blue binding box. The one just on top of the aircraft is highlighted with a pink bounding box, while the diver on the left side is highlighted in what looks like a green bounding box. But the real surprise happens when the user resubmits the image. Again, the model brilliantly identifies the plane wreck. However, this time, it goes over and beyond to spot the divers in the background. Quoting the model's response, it says, "This image features a large old rusted airplane sitting on the ocean floor. Divers are swimming around the airplane, exploring its structure and exploring the surrounding area. There are several people in the scene, some of them closer to the plane, and others further away. The divers are spread out across the image, with some closer to the airplane and others in the back." You'll agree that the description given by KOSMOS 2 is absolutely spot on. In this next demonstration, an assistant professor of machine learning and computer vision at the University of Cambridge, Samuel Albani, uploaded his picture, and the response from KOSMOS 2 was quite interesting. First, it interprets the elements and content of the image as a young man with glasses is standing outside, smiling at the camera. He has curly hair and a blue shirt. Remarkably, each element in the image is highlighted with a distinctive color of bounding box. Samuel's hair and his glasses were highlighted with a red bounding box. His curly hair was highlighted with a light green bounding box, while the green bounding box is used to highlight the blue shirt. Here, another user inputs an image of a black sneaker placed on a drink box. According to KOSMOS 2, this image features a pair of black sneakers sitting on top of a shoebox. The sneakers are placed on a beige carpet, and the box is placed on the floor. Essentially, the model was correct in all of its descriptions except for the part where it says a pair of sneakers and shoebox, because clearly there's only one shoe in the image, and the box underneath the shoe is not a shoebox. Instead, it's a box of multi-pack Diet Coke and other products from the Coca-Cola brand. But other than these small errors, all of the responses generated by KOSMOS 2 were satisfactory. According to reports, this intuitive model has a 91.3% accuracy in identifying phrases in objects and images. This is quite exceptional compared to the accuracy of other models, which is around 86.7% at most. The superiority of KOSMOS 2 is down to the impressive new features it was equipped with, including zero-shot learning and grounding. Essentially, zero-shot learning is the ability of a large language model to recognize and do things that it was not taught during the training process. Grounding, on the other hand, is the process of using large language models with use case specific and relevant data that the model wasn't trained on. Critically, the grounding technique helps to improve the quality, accuracy, and relevance of the generated output by a large language model. So far, Microsoft's KOSMOS 2 is the only large language model that has been able to efficiently and effectively combine all of these brilliant features, and it's hard to see how other language models will compete against it when it is finally released for commercial use.